How are you, my friends? This is Calculus 1 solved questions applying L'Hopital's rule, part 2. Please, you can go and check part 1 for more questions. Question number 1, find the limit of this function 2 minus e to the x minus e to the power minus x, all divided by 2x squared as x goes to 0. So first we check the L'Hopital's condition. We replace x by 0, we get 2 minus e to the power 0 minus e to the power minus 0 over 2 times 0 squared. So this is 2 minus 1 over 0. So that's 0 over 0. This is the L'Hopital's condition, or infinity over infinity. So we can apply the L'Hopital's rule, which says, take the limit of this function. It will be the same limit as the derivative of the numerator divided by the derivative of the denominator. This is not similar to quotient rule, please. So the derivative of only the numerator, this will be 0. The derivative of 2 will be 0. And this will be minus e to the x. And there is a minus here. And the derivative of e to the minus x will be another minus. So this becomes plus e to the power minus x over 4x. Let's replace x by 0. So this is minus e to the power 0 minus 1 plus 1, 0 over 0. So we can apply L'Hopital's rule again. So take the derivative of the numerator here. Take the derivative of the denominator. So this becomes minus e to the x minus e to the power minus x divided by 4, which is the derivative of 4x. Now replace x by 0, e to the power 0, there is a minus here, and another minus e to the power minus 0, so that will be minus 1 divided by 4, and the whole limit will be minus half. Question number 2 is really nice question. Find the limit of x minus tan x divided by x cubed as x goes to 0. So let's try the L'Hopital's condition. I replace x by 0, so it will be 0 minus tan of 0 over 0 cubed, which is 0 over 0. Now let's apply L'Hopital's rule. Find the derivative of the numerator, which is 1 minus secant squared of x, the derivative of tan of x. The derivative of x cubed will be 3x squared. Now replace x by 0. This will be 1 minus secant of the 0 divided by 3 0 squared. Again, 0 over 0. We can apply L'Hopital's rule for the second time. So let's find the derivative of this. 1 minus secant squared of x. The derivative of the 1 is 0. That's a constant. Minus the derivative of secant squared of x will be 2 secant of x to the power 1 times the derivative of the inside secant of x, which will be secant of x times tan of x. And this will be the derivative 6x. Now let's simplify more. Cancel the 2 here. So we get minus secant of x becomes secant of x all squared. And now here we have tan of x. We can replace it by sine of x divided by cosine of x. And there is an x here, and there is also 3. Let's rearrange again. Minus 1 over 3. So I leave it. This is a constant. The limit of secant of x all squared, or we can write also secant squared of x. That will be the same over cosine of the x times the limit of sine of x divided by x as x goes to 0. This will be 1 here. And replace x by 0. Secant of 0 will be 1 squared. Cosine of the 0 will be also 1. So when you multiply everything, you get the whole limit as minus 1/3. Question number 3 says, find the limit of the function e to the power 3x minus e to the power minus 9x, all divided by ln of 1 plus x as x goes to 0. So first we check the L'Hopital's condition. We replace x by 0, e to the power 0 minus e to the power minus 0 over ln of 1 plus 0, which is 1. ln of 1 is 0, and this is e to the power 0, 1 minus 1. So we have 0 over 0. So we can apply L'Hopital's rule. Now find the derivative of the numerator. It will be 3 e to the power 3x minus, there is a minus 9 here from the derivative of minus 9x times e to the power minus 9x. divided by the derivative of ln 1 plus x will be 1 over 1 plus x. So now we have minus and minus 9 becomes plus 9. We replace x by 0. So 3 e to the power 0 plus 9 e to the power 0 over 1 plus 0, which is 12 is the limit. Question number 4, find the limit of cosine of 2x minus 1 over x to the power 10 as x goes to 0. Now let's check the L'Hopital's condition. Cosine of the 0 is 1 minus 1 over 0 to the power 10 is 0. So 0 over 0, we can apply L'Hopital's rule. So we find the derivative of the cosine of 2x, which is minus 2 sine of 2x, and the derivative of minus 1 is 0. The derivative of x to the power 10 will be 10x to the power 9. Replace x by 0, we get 0 over 0 again. So we can apply L'Hopital's rule for the second time. Let's find the derivative of this. Minus 2 sine of 2x, it becomes minus 4 cosine of 2x divided by 90 x to the power 8. Bring 9 down and subtract 1. Now let's rearrange this. Minus 4, you can see that here, minus 4 over 90, that's a constant there. Limit of this function cosine of 2x as x goes to 0, and we have a limit of x to the power 8 as x goes to 0. The cosine of the 0 will be 1, so minus 4 times 1 is minus 4, and the limit of x to the power 8 as x goes to 0 will be 0, so 90 times 0, 0. So the final answer minus 4 divided by 0, which is undefined, so the limit is minus infinity. Question number 5, not easy question. Let's see, find the limit of x plus sine of x divided by 3x plus cosine of x, x goes to infinity. Let's apply and check the L'Hopital's rule. X goes to infinity, so this will be infinity over infinity. Let's apply L'Hopital's rule. Find the derivative of x plus sine of x. So it will be 1 plus cosine of x. The derivative in the denominator will be 3 minus sine of x. Also, if we replace x by infinity, it will be plus infinity over plus infinity. So we can apply L'Hopital's rule again. The derivative of 1 plus cosine of x will be minus sine of x, and the derivative of 3 minus sine of x will be minus cosine of the x. Also, this will be infinity over infinity. So the limit on the right side here does not exist. So from the last slide, we see that the L'Hopital's rule fails here, and this is very rare. So we have to use another way, another method, another technique. Let's divide all terms by x. So x over x, sine of x over x, 3x over x, cosine of x over x. And let's take the limit as x goes to infinity. So this is 1 plus sine of x over x as x goes to infinity will be 0 by sandwich theorem or squeeze theorem, because sine of x between minus 1 and 1 divide by x, the limit will be 0. This is lecture number 4. The same thing for limit of cosine of x over x as x goes to infinity will be also 0. So this limit is 0, this limit is 0, and this is 1 divided by 3, and the whole limit is 1/3. Question number 6 is a nice question. Find the limit of all this fraction. The limit of sine of 2 theta minus cosine of 5 theta plus tan of 3 theta plus 1 over sine of 3 theta plus cosine of 6 theta minus tan of 2 theta minus 1 as theta goes to 0. Now let's rearrange all the terms and divide them by theta. Each term we can divide by theta. Sine of 2 theta divide by theta, divide by theta. Tan 3 theta, I can leave it here. Now I will combine, you will see why, 1 and minus cosine of 5 theta together divide by theta. In the denominator, it will be sine 3 theta divided by theta, and the minus tan of 2 theta divided by theta. I will combine cosine of 6 theta minus 1 term here, all divided by theta. Now let's take the last term in the numerator here, this one, 1 minus cosine 5 theta over theta. I will study that here. If I replace theta by 0, 1 minus cosine of 0, so it will be 1 minus 1 divided by 0, which is 0 over 0. So I can apply L'Hopital's rule on this term here, the third term. So I find the derivative over the derivative, and then I replace theta by 0, it will be 0. So this limit will be 0. Same thing here down. This limit will be 0. We can apply L'Hopital's rule. Now let's see the first two terms in the numerator and the first two terms in the denominator. We have sine 2 theta divided by theta. I need to multiply up and down by 2. You will see why. Let's look here. Remember, the limit of sine x over x as x goes to 0 will be 1. Also, if we put sine 5x over 5x will be also 1. So when I put sine 2 theta over 2 theta, this is 2 theta like x. So the limit here will be only this 2, and inside we get the limit 1. Same thing for tan 3 theta. I will multiply up and down by 3. So I leave the coefficient, and then tan of 3 theta over 3 theta, this will be also the same rule here. Tan of theta over theta, the limit as theta goes to 0 will be also 1. This one here the same. I can multiply up and down by 3, and here I can multiply up and down by 2. So when I find the limit, it will be 2 times 1 plus 3 times 1 over 3 times 1 minus 2 times 1, and the whole limit is 5. Now, for more questions on L'Hopital's rule, please, you can see the lecture number 21 in the Calculus 1 lectures. And for more questions on Calculus 1 in general, you can visit the playlist Calculus 1 Solved Questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.